This will be the 10th problem in my series. In this video, we'll look at another series parallel circuit problem. Once I am finished with this series of problems, I will be posting them in my stand store at this web address. This direct current circuit contains 19 resistors arranged as shown here and is connected to a power supply of 460 volts. Our task in this problem is to compute the current through and the voltage drops across each resistor in the circuit. The first step is to label all the sections and mark the direction of current through each resistor. The equivalent resistance of a series parallel combination of resistors can be found by successive application of the rules for combining series and parallel resistors. In a series circuit, the total or equivalent resistance is equal to the sum of the values of the individual resistors. Calculating all of the series equivalents of this circuit, we get the series resistance D to E is R13 plus R14. The series resistance between C to G is R7 plus R8. And the series resistance between G to F is R10 plus R11. Replacing these series resistors with a single resistor equivalent, our circuit now looks like this. Now let's work on the parallel resistors. In the case of two resistors in parallel, the equivalent resistance can be found using the following equation. Of note, the equivalent parallel resistance is always less than the smaller of the two resistors. In section C to G, R5 in parallel with R6, it is calculated to be 600 ohms. Section C to G now consists of two 600 ohm resistors in parallel. In a case of a circuit of n equal resistors in parallel, the total or equivalent resistance can be determined from the following equation, where R is the resistance of each of the parallel resistors and N is the number of resistors connected in parallel. For section C to G, the resistance is calculated to be 300 ohms, and the equivalent circuit now looks like this. For section B to C, the equivalent parallel resistance is equal to 33 1/2 ohms. For section EF, the equivalent resistance is 52 ohms, and for section GF, the equivalent resistance is 300 ohms. In a circuit of three or more unequal resistors in parallel, the total or equivalent resistance, Req, is first found by finding the reciprocal of Req, which is equal to the sum of the reciprocals of the individual resistances. Calculating the equivalent resistances of the elements connected in parallel in section DE, 1 over Req is equal to 1 over 100 plus 1 over 200 plus 1 over 600, which works out to 60 ohms. Replacing the three parallel resistors now, calculating the parallel resistance between D and E is equal to 48 ohms, and our equivalent circuit now becomes Finally, we combine the remaining series resistances. RAC is equal to 53 1/3 ohms. And we have two branches between RCF. This branch of RCF is equal to 600 ohms, and this branch of RCF is equal to 120 ohms. Our series parallel circuit now looks like this. The final or total equivalent resistance is REQT, which is equal to 53 1/3 plus the parallel resistance of 600 and 120 ohms in parallel, which equals 153 1/3 ohms, giving the final equivalent circuit that can be represented looks like this. And we compute the total line current using Ohm's law. I1 is equal to E divided by REQT, where E is the power supply voltage, and I1 works out to be 3 amps. We are now in a position to compute the current through the voltage drops across each resistor in the original circuit. Stay tuned for the second half of this video where we will do just that. This video is part of my electrical technical information series. In this series, I will be covering essential topics to help you understand electrical systems. These topics are small excerpts from my courses located in my stand store, which you can access by going to this web address. Before exiting this video, I want to make you aware of some huge sales that are coming up for members of Bluetti. Bluetti is a company that specializes in portable power stations, solar generators, and battery storage systems. It offers eco-friendly and reliable power solutions for outdoor activities, emergencies, and off-grid living. Their products include high-capacity lithium batteries with multiple outlets such as USB, AC, and DC, and compatibility with solar panels, making them ideal for providing power in remote locations during power outages. Bluetti is popular among campers, RV owners, and those seeking sustainable energy solutions. Their power stations come in various sizes and capacities, catering to different energy needs. To find out more and take advantage of this sale, simply click on this web address.